find, because it says write an equation for this graph, looking at the graph, what kind of equation is this? So exponential equation looks like what? AB to the X, and A stands for, and B is multiplier. When we're writing the equation from a graph, I still make a table. You don't have to. Cool. You want to find 2 points that it goes through where it goes through the corner. So like right here, it goes through that point at 0, 5. Can you find another point where it goes through like the corner of the grid? -1, 10. Okay. So -1, 10, 0, 5. And we want to find the multiplier. Not what I'm dividing by, what I am multiplying by. So 10 times something gives us 5. We know 10 divided by 2 gives us 5, but for our multiplying, we just divide it. 5 divided by 10, which is 1/2. Our equation is y equals, what's my a value? 5 times 1/2 to the x. Just 5. Wherever your 0 is, your start, that's your a.
Oh wait, I thought the middle was.
All right, and then 11. So it's exponential growth through decay. It's telling us it's exponential, so it still equals y. So it's still y equals ab to the x. A new social media site is increasing its user base by approximately 5% each month. So if it's increasing by 5% each month, how do I find my multiplier? Add it to 100%. 105, which, yes, I heard someone say 1.05 is our multiplier. The site currently has 36,100 users. So that's our a value. So y equals 36,100 times 1.05 to the power of x. So so 36,100 is right here. I'm going to graph it just by multiplying 36,100 by 1.05 over and over again. Let me see if I can get that brighter. So almost 38,000. Almost 40,000. Close to 42,000. Close to 44,000. Notice every box is 5,000 here. $46,000. 48,000. 51 almost. 53,000. 56,000 and almost 59,000.
We have to like graph the whole entire
Do we have to not necessarily. This looks linear. It's not. Anyone have a guess as to why it kind of looks linear? Yeah, how small it's increasing. This multiplier is really close to 1. If our multiplier is 1, it's linear. Since it's close to 1, it doesn't grow quickly. We want to know what's the user base 8 months from now, which we could look at our graph, but it's not very accurate. So we just plug in 8 for x. So 36,100 times 1.05 to the power of 8. And I get 53,336. I'm rounding to the nearest whole number. Because, anyone have an idea of why? Half a person, yeah, we're talking about users, how many people there are. Okay. Questions on the warm-up before we move on? So problem 40, y equals negative 2x plus 3. We're gonna graph this. Going way back to chapter 2, graphing our lines. I know you guys keep saying you want this back, right? No more triangles.
I'm more of a systems of equations type of guy.
So, y equals mx plus b. What does the negative 2 stand for here? The slope. So our slope, we usually want it as a fraction. So how do I write that as a fraction? 2/1. And what way does that mean we move on our graph? What way 2 and what way 1? Negative 2.
Down 2.
Over 1, over what way? Down 2.
Did I say negative?
It was a 50-50 chance.
Down 2, right 1. Yes, the slope is negative 2. You don't need to write this part in purple if you remember how to graph lines. If you're going to need this reminder, then yes, you want to write it. And then the 3, that's your start. Y-intercept. So I start at 3. I go down 2, right 1, down 2, right 1, down 2, right 1. What is the opposite of down 2, right 1? Up 2, left 1. So is negative 1, 5 a solution? How do we test if a point is a solution? Plug it in. So when I plug this in, I'm checking. So this is x, this is y. Does 5 equal negative 2 times 1 plus 3?
Wait a second. I'm sorry.
Negative 1. Need more time? Okay. So we're checking if negative 1, 5 is a solution. So we're going to plug it in. Negative 2 times negative 1 is negative 2 times negative 1 plus 3?
Yeah.
5, yes. So 5 equals 5 is true. So that means negative 1, 5 is a solution. We know because it made the equation true. What about the graph? And it is on the line. So negative 1, 5, this point right here is on the line. I don't know why that takes so long to focus. So we didn't necessarily even have to plug it in, right? We could have just looked at the graph. You could say it's on the line. Yes, this is just like a warm-up question from the book, not our warm-ups. 2, negative 1. Is 2, negative 1 a solution? Yes, no, maybe? Yes, how do you know?
Negative 4 plus 3. Shucks.
Yes, it is on the line. Or, bless you, yeah, you can plug it in. 2 times, so -2 times 2 is -4 plus 3 is -1, but it's this point right here. And C is 0, 0. Is 0, 0 a solution?
No.
And I'm gonna show this one algebraically just because it's false. So 0 doesn't equal 3. So it's not a solution. Because it's not true. And 0, 0 is not on the line. So that's how we can tell if points are solutions to equations. But what about inequalities? Yeah. So inequalities in two variables. We're going to turn 41 into our notes. Thank you. Yes. Yeah. Okay, so our inequality right now is y is greater than or equal to -2x plus 3.
Did that say 941?
Yes, 9-41.
I got confused.
So I'm going to give your group a some points to test in this equation, inequality, not equation, sorry. And you're going to decide if they are true or false. I only want to know what ones are true. You're going to share them with me and I will put them on the graph. All right, so on our graph here, which I didn't set up ahead of time, you tested your points. I only want to know which points are true. No, we're doing it right now. All right, so if you had a point that is true, will you tell me the coordinates? 4, -1. Anyone else a point that's true? 3, 1.
What's the highest like X and Y value that we have?
I don't know. I know there are more than 2 points that were true. I need all of them. What do you got, Julia? 0, 3. Ben, you have one?
No, I don't know which one it says.
It doesn't matter.
You want true ones?
True ones. Only all the points that you plugged in that made it true.
3, 5. Yeah.
That's fine. It works. I believe you. Every group should have at least 3 points that are true. 3, 6.
Oh,
36. Oh, shucks.
It's not a big deal if it doesn't quite fit.
Okay.
What do you got, Issa? 5, 2, 1, 3.
It's just kind of starting to look like, remember that little picture we had to draw for the graph?
2, 2 works.
So this might be wrong because it was Will.
Okay.
But 3, 3.
3, 3 works. That's not wrong.
That's not removing me, Bronco.
Okay, so there should be a lot more. Anyone, 1 or 2 more? What do you got? 3, -3, 1, 4. So we're gonna graph the line y equals -2x plus 3 again. Notice it is the same as problem 40, except this one's an inequality.
I was gonna ask,
Oh, they just have to be on like that
if
side of the
negative-
domain. Oh, let's go.
Okay, so we had the point 0, 3 that's on the line was true. The point -3, sorry, 3, -3 was true. Points on the line, do you think they're true or false? Yes, they're true.
Yes.
What about this point right here? If I tested this point, do you think it would be true?
I mean, not, because it's not on the line.
It's not on the line, but all these points were true.
Because it's greater than.
If I test a point down here in the third quadrant, is it gonna be true or false? False. So all of these points over here make this equation true. So there are infinitely many solutions, yes. Just like a one variable inequality, when we shade on a number line, same idea. So here, what you do, I'm gonna list the steps how we did last week. The first thing you do is graph the line. You just pretend like it says equals. If you have less than or greater than, you have a dashed line. And if you have or equal to, you have a solid line. Just like an open and closed circle on the one variable inequalities. So the solid line, like we had here, that means points on the line are solutions. If it's a dashed line, do you think points on the line are solutions or are not solutions? Are not, it's the opposite. So if we plug this point in here, 0, 3, you got 3 is greater than or equal to 3. If it didn't have the or equal to, it would just say 3 is greater than 3, which isn't true. So you graph the line solid or dashed. Step 2, test any point. For this problem, we tested a lot of points. Any point not on the line. So test any point not on the line. What point do you think I'm going to recommend that you test? 0, 0. When we test 0, 0, we are asking, is this true? So 0 is greater than or equal to -2 times 0 plus 3. This is a question. I want to know, is this true or false? So 0 is greater than or equal to -2 times 0 is 0 plus 3 is 3. Is that true or false? False. What does that mean? So 0, 0, we know it's not on the line. This means is not a solution. Step 3 here is to shade the solutions. The solutions are all the points that make it true. So if 0, 0 is not a solution, and that's right here. So we shade, for this example, the opposite side of the line.
Yeah, I was just starting to get a little number like this.
So shade the opposite side of the line. So 0, 0 right here is false, doesn't work. So we go to the other side of the line. Every point over here is a solution. This is our boundary line. We don't cross it. You shade everything over here.
Like exactly like that.
However you want, you can color it all in a lot nicer. Doesn't matter.
I like that idea.
Anything over here is a solution. So any of these points will work. Anything down here, if I plug this point in, will not be a solution. All right, so 42. you're going to try this. Y is less than negative 2x plus 3. Notice it is the same y equals mx plus b, except we have a less than this time. Oh, you were, well, no, that last problem, we just tested a lot of points to figure out kind of the shading. But you only have to test, how many points do you need to test to determine the shading?
Like 3 maybe, I don't know.
We just took notes on it.
Oh, one.
One.
Sorry. I'm thinking like. I was thinking 3 just to be sure.
It's like, one is just a thing that's true.
According to the scientific notation, you have to.
All right, so y is less than negative 2x plus 3. When you are, so our line is the same. We start at 3, our slope is down to right 1, down to right 1, or up to left 1. Should my line be solid or dashed?
I'm gonna say dash.
Dashed. And what does that mean?
It's not a solution.
The points on the line are not solutions.
You not hear what she just said?
No.
Okay.
So these points are not solutions because it's dashed. Notice I just have some little gaps in between. Again, if I plug in the point 0, 3, it's going to say 3 is less than 3. That's not true. False. These points are not solutions. Yes, you can plug in 0, 0. What points are you not allowed to plug in?
The boundary points are 3, 2. I think it's 3.
The points on the line. Never.
Oh, no, on hers.
That's not true. Inequalities do have some use, but like, are you going to make a graph like this? No, probably not. Probably not like this. 0 is less than negative 2 times 0 plus 3. We're checking if this is true or false. I get 0 is less than 3.
That's definitely true, man.
That's true. So what does that mean?
That 0 is indeed a solution.
0, 0 is a solution. So do we shade where 0, 0 is or the other side of the line?
Where 0, 0 is.
So 0, 0 is down here. So I shade everything on this side of the line. Do not cross that boundary line. You can cross your X and Y axes. You just can't cross this line.
Okay.
If I plugged in the point 1, 2, sorry, 2, 1, 2, 1, would this be a solution? No. What about the point negative 3, negative 7? Yeah. What about the point 1, 1?
Wait, yeah, sure.
It's on the line. No, because it's a dashed line. All right, and 43, I'm going to turn the page, and you're going to try a couple on your own or with your group.
Oh, we got 43. Okay. I'm gonna have to do that.
Y is greater than negative 1/3 x minus 1.
It's definitely going to E.
So we're only going to do A and B.
Oh, see, I told you, Will. Keep it.
Yeah, whatever. We got that.
And Y is less than or equal to 4x plus 2.
If I told you, did it.
It's okay.
That's good. That's good, man. No, I actually do it one time, and not even reports.
It was pretty quiet for me.
Okay, so you are trying these on your own. You're going to graph them, determine if it's solid or dashed. Then you're going to test a point. The point determines if determines your shading. If it is true, you shade there. If it is not true, shade the other side. I'll give you guys about 5 minutes to work on these, and then we'll go over them. Here on A, ladies and gentlemen, thank you. -1 is your y-intercept, down 1, right 3, down 1, right 3, or up 1, left 3. Is this solid or dashed? A. A is dashed because it doesn't have or equal to. And what does that mean again, though?
It's not solution.
The points on the line are not a solution. So if we test 0, 0, 0 is greater than negative 1/3 times 0 minus 1. 0 is greater than negative 1. True or false? Is 0 greater than negative 1?
Yes.
True. So what does that mean?
It's pretty true. I mean, then you shade towards 0, 0.
You shade towards 0, 0. Everything on this side of the line. Again, you can cross the axes. You can't cross that boundary line. And B, y is less than or equal to 4x plus 2, y-intercept of 2. My slope is 4. What does that mean I do? What's the opposite of up 4, right one? Down 4, left one. Solid or dashed? Solid. Solid line, that means the point 0, 2 is a solution. So test 0, 0. 0 is less than or equal to 4 times 0 plus 2. 0 is less than or equal to 4 times 0, 0 plus 2 is 2. True or false? True. That means all of this, including where I just wrote all that, is shaded.
I like that you are next to
Make sure you do not cross your boundary line. What does the shading represent again?
the parts that are solutions.
The parts that are solutions. So let me just say, is 5, negative 7 a solution here? Yeah, is negative 1, 2 a solution? No, what about negative 1, negative 7?
Yeah,
Yeah, because it's down here somewhere.
somewhere.
All right. Questions?
No, I think that's it, man.